everyone. This is Agung. I'm going to present a project about house price predictions. This is for CISD 43, Big Data, Spring 2025. The problem statement is about predicting house prices based on house age, average income, average number of rooms, average number of bedrooms, and area populations. In here, we're using Pandas, Matplotlib, Seaborn, PyMongo, and the tech machine learning that we use is actually we're using two kinds of machine learning techniques. Gradient booster regressions is we're making predictions based on wisdom of the crowd. Imagine that we have a lot of and make prediction. Usually that's what it means. It's and the second technique is actually using a linear regression technique. It draws a trend line, a Fourier series through data points to make predictions. Here, I'm going to start with the exploratory data analysis. I will be fetching the data, U.S. house data, display the statistics, and when I try look at the data right here, I see that uh, some address is actually refers to U.S. military bases, which probably will not be a real a house address. So what I do is I drop them. This actually happens when I try to extract the state of these addresses. So if it's like this U.S. military address, it'll say none. So I don't think it's marketable, and it's probably a bogus data. So I drop them and I do a little bit modifications to the data, such as like the house average, like 7.188236, and room numbers. I don't think in a room, this is actually a room number. So what I do is just making all these numbers, these decimals would be either 0 or 5. So yeah, this is data that has U.S. military um, um, address or a PO box address, which is not, uh, I don't think it's a real address. So I drop them. And this is the technique that I use to uh, change the decimals into either 5 or 0. So it's more readable and it's human reasonable. Um, and I check for any null values. I do a histogram of the data, income, um, house, the year of the house, the number of bedrooms, the number of rooms, populations, and the price. Everything looks good. And I sort uh, the number of cells uh, between for each state. So I know what state that sell the least and what state is actually sell the most. This is actually GU, Guam. It's actually a United States territory in Southeast Asia, I think. So it's far from United States. And I do some um, a query to look at the sales in Virginia just to make sure the price is actually for the minimum is actually uh, still in the range. This is for Virginia sales, and this is for um, Guam sales. If you see the price, the minimum is 300,000. Here, the price in Virginia, the minimum will be like 600,000, which is a big gap, and that's the reason maybe why um, house prices in Guam is actually sell faster rather than Virginia or anywhere else. I do some plotting price to number of rooms. number of bedrooms, and I do for this is for the machine learning coding sections. I do price correlations metrics, and oh, okay. Uh, this is for the machine learning part. Actually, um, preparing the machine learning stuff, and I check the scoring. It's actually for gradient booster. It scored only 88%, while the linear regression scores 91%. This is for the database part with MongoDB. Um, this is the MongoDB. Um, oops. And I do for database part, I do some query. I do regex where all the address is actually from Virginia, the sales in Virginia. Um, I do count the number of sales in California. It's actually 78, and I sum the number of sales in it's 94 million, while the total sales is 5 billion, 5.5 billion. And I do for rapid mining process. This is for gradient booster process. The result is uh, quite close, whereas the price is 106,000 and it's 107, 105, 160,000, 160,000, and they pretty much almost the same. It's the error is about like 10%, more or take. This is for gradient booster, and for linear regressions is pretty much closer, has closer accuracy, better accuracy. Here the error is actually is about 8%, or better than linear regressions. Conclusions, I think this is a great learning part of tools. I learned great stuff. um, uh, Thank you so much.